Good evening, everyone.
Good evening, sir.
Good evening,
Good
sir.
evening. I hope I am audible.
Good evening, sir.
Yes, sir.
Audible, sir.
Yeah. See, already I hope you all checked the Moodle site. I have uploaded all the slides material which is covered by me, and also the assignments. Okay, and in between I will announce well in advance, and then I may ask you to do some quizzes also in between, but I will give sufficient time. Please occasionally review the Moodle site and daily open the Moodle site and check it. Of course, you may get some message also, but 1 week in advance I will inform whatever I do. Okay. So, how was the interaction session? Before starting my class, I would like to take some of your feedback experiences about interactive session. Can anybody tell how was the interaction session with IIT Madras? How many of you have attended?
Yes, sir. Good evening, sir.
Yeah.
Yeah, today's class it is very good, sir. That is taken by the Gafur.
Okay.
It is good,
All
sir.
doubts in are cleared?
Yes, sir. Yes, sir. The concepts what he has discussed all are clear, sir. Along with the discussion in between, he has asked some MCQ questions.
Okay.
Like that interaction class is very nice, sir.
Okay. So that means whatever the assignments you are supposed to do in data science course, he has assisted you to in solving those questions comfortably?
Yes, sir. Yes, sir.
Okay. Okay. So because the majority of the content prepared in data science for engineers course is completely based on R. Okay. So
Yes, sir.
some of the codes I also gave in my presentations. All those codes you can run it in R Studio or in R Prompt very easily, and then you can visualize and then understand the graphical features also. Entire code is tested by me in R Studio, and then I included in the slides. Okay, now what we have to do is, do you require any testing on R again? I will not do, because R anyway you are going to do with the NPTEL, and whatever the learning and assessment happening there is as it is, we will take it here. So therefore, I am not interested. But if you want to have any examination test is required, I can conduct in R. That depends on your interest, okay, for practice point of view. But see that all of you submit the assignments in R very systematically within the deadline. If you cross the deadline, if you don't submit the assignments, you lose marks in that assignment. Even if you put your effort, you may not get marks. That's why please stick to the deadlines of assignments in R, because whatever the assignment marks you are getting there, all those things we will consider here for your assessment of the grade also, as I mentioned on the day one. Okay. So all those presentations and materials, everything is uploaded in the Moodle site, and in between I am also digging my old videos prepared by me. Some of the videos related to data warehousing and analytics also I will try to upload, so that you can go through the videos also whenever you require some assistance. Okay. So with these things, let me start for today's lecture. Today and tomorrow I am going to take lectures. Afterwards, some topics I reserved for physical lecturing. I don't want to complete everything in online mode. I want to do it some lectures and tests. All those things I'll do it in physical mode whenever you come to Kurnool. that time we will have sessions. That's what already I mentioned to the concerned coordinator of Kurnool. So he also accepted. But today and tomorrow we will continue the topics of related to OLAP and other things. I hope slide is visible.
Yes, sir. Visible, sir.
Okay. See, already we started this related to this concept. I talked about the importance of SQL. Then one of your participant, she gave a presentation how to learn SQL using AI tools, and then I gave concept of modeling, multi-dimension model, and the entire design principles we have not discussed here because that is not related to your topics. That's why I concentrated only on practical aspects. And also I introduced what is OLTP system and what is the traditional transaction processing and examples, how the file systems are different, and then the importance of OLAP and multidimensional modeling. Now today we talk about how this OLAP to perform certain operations on OLAP, what is the support the relational database systems are providing. That I will cover today. So the title of the talk is Relational DBMS Support for OLAP. So these two are the two different subtopics of this lecture. In fact, I prepared around 45 to 50 lectures on this concept when it was coined in 2000. Sorry, 2002-3. Afterwards, I refined. So as I mentioned, there are 5 different basic operators which are part of OLAP. Slicing. Slicing means you are cutting horizontal subset of the structure. That's called slicing. Dicing, it's a vertical. And then drill down, moving from high level concept to lower level concept. Drill up, which is a reverse process, moving from lower level data to higher level data. And then pivoting, which is a rotation, changing the dimensional, reorganizing the dimensions by changing the orientation. So that is called pivoting. So once the data cube, which is I mentioned in the last class, a data cube is a multidimensional structure basically used to represent the different types of measures that are calculated or computed or derived across the different dimensions. Everything is shown in the form of a nice structure so that the analysts can play with the data cube by performing operations which are listed here on the slide. So these operations are called OLAP operations. Now we will go into the details of each one. What is slicing? The slicing, the operation basically focuses the data values on a subset of dimensions. Suppose if you have n-dimensional database, n-dimensional cube, I may focus only nth dimension and second dimension and n minus k dimension. Then I will do slicing by discarding the unwanted dimensions out of the structure. That's why focus attention on subset of dimensions. So that means what? Replacing a dimension with a single member value or with a summary of its measure values. Either I can replace with a single value or I can generalize into the collection of values related to that group. That is called slicing. So basically it is a manipulation, but you are not disturbing the original transactional data. We are only already whatever transactions are happened on a particular application, that data only you are manipulating by using this operation. So this is basically, as I said, it is a projection. Projection is nothing but a vertical subset. Vertical subset means in a table when you have rows and columns, if I discard certain columns, Then if I retain some more unwanted columns and unwanted columns are discarded, it is called vertical subset. That means all the properties or all the attribute values of all the rows are taken into consideration only for certain columns, not for all columns. That's why it's called a projection. Projection is a vertical subset. Then second operation is called dicing. Dicing imitates the selection operation. Selection is a horizontal subset. For example, find the faculty who are attending from Telangana state. That means I am taking all the properties of every participant of Telangana state only. That means I am discarding all the characteristics of all the people from other than Telangana states. That's called selection. Selection is a horizontal subset. That means from a large table, only some of the rows are taken into consideration. Whereas in the earlier example, projection is a only all the properties of certain columns for all the people are taken. That's called vertical subset. So horizontal is slicing, vertical is called dicing. Then comes drill down. Drill down is obtaining more detailed values, more details about a dimension. For example, if I take a time dimension, I can say time is can be considered as a year. Now, can I go to the details about year? A year is a collection of months. Can I go some more details about year? So I can say each month is a collection of days. Can I go further? Each day is a collection of hours. Can I go still further? Each hour is a collection of minutes, collection of seconds. So like that is called detailing. That means when a particular higher level, if I take sales, year-wise sales, I am going to detailed about sales of all products at every level, either month level or quarter level or hourly level or day level or week level or minute level. It's called detailing. That means what? You are navigating from a more general level to a more specific level. More general level to more specific level. This is called drill down. So basically, this general level is also an aggregation. Detail level is also aggregation. But when you take the summations of the lower level sums, the highest level sum will come. That is called drill up. Drill down is reverse. So then drill up is also known as roll up. Summarizing the data about a dimension. For example, I will take a participants. What are the average age values of all participants? Suppose if I have a highest level average age value of all participants, then can I get a average age value of for each state participant? Can I get an average age value for each district level participants within a state? Can I get average age value for each village or town? So that means what? You are aggregating to highest level from the bottom levels. So that's called we are navigating from a specific level to a particular generalization which is higher than the current generation, current level. So this is called drill down, drill up or roll up. Drill down, drill up, or roll down or roll up. Up means you are going to high level of generalization. Down means you are going to the deeper inside, more minute values. More minute values is called drill down. Then pivot. Pivot means present the data, the same data you are presenting in different orientation, different directions, different combination, swapping of the values or rearranging of the dimensions in a data cube is known as pivoting. So when the data multidimensional cube is constructed, the analyst is always how the cube is built, analyst doesn't aware. But analyst will only take this as a cube and then he will manipulate the cube the way he wants. How he will manipulate? The manipulation is done by performing these operations sequentially one after the other. You may cut horizontally, you may cut vertically, you may rotate, you may drill down, you may drill up. All possible combinations he is playing with the cube. Like a kid's plays during childhood days cube, he is playing with the cube with rotation, vertical, horizontal, rotation, drill down, drill up, etc. So these operations will provide the complete analysis, 360 degree analysis for the analysts or executives. That's why this is known as analytical structure. So now I will give some couple of examples here. So these examples not only helps you to understand the aggregations and roll up and drill down, but also you will get familiarized with the SQL operations also. So now, for example, if you take I am having a data of sales, product ID, store ID, date and amount. Now I am writing I want to add all the amounts for a particular day, for a day one. That means what? I want to print the total amount of day one. Now, without worrying query, how it is calculated, you just visualize from this picture. Can anybody tell how it is calculated? Yes?
Sir, it is added with the date having one.
Yeah, it is added. What is added?
The amount is added.
Amount is added.
The amount is added.
That
Where the
means
date
what?
equals to 1.
Yes, that means what? You have rows, right? You have 6 rows here, right? In these 6 rows, you are first taking a horizontal subset of rows where the date value is 1, right? That means what? So when you take horizontal subset, we get first row. Yes, his date is 1. Yes, so pick up the row. Then second row, his date is 1. Pick up the row. Third row, pick up the row. Fourth row, pick up the row. Fifth row, no, date value is non-1. So drop it. Sixth row, drop it. So this is over. So out of 6 rows, we have taken only 4 rows because we want to add amounts for day 1 only. Now that means what? Date is equal to 1. All values, date values are same. Now what we are doing? We want to add the corresponding amounts of these rows, selected rows. The selected rows are 4, first 4 rows. So the corresponding amounts gets added. Some amount, EMT is a column. So I'm showing you the slide here because with mouse, I think mouse is also visible here. The EMT is column. So this gets added. So that means all these 4 rows gets added. And then the value output is shown here to understand. Now, this is also practice for SQL also. How SQL does this? What is SQL says? SQL always basic structure of SQL is select from where. Simple SQL is select from where. So in the select means which column I want to select. There is no column sum AMT here. But sum AMT column you are generating. Sum is an aggregate function. It is aggregation means sum. Sum is aggregate function. Max is aggregate function. Minimum is aggregate function. Okay. And then count is an aggregate function. So you are combining all the value and you are putting a nickname for that number. Whatever number you get. In this example, we are getting 81. So the nickname is some amount. Then you don't want to select all columns of exist of the database table. Here I am showing only 6 tables, but in your database there may be thousands of tables, thousands of rows. Out of these rows, we are only selecting those rows whose date value is 1. So that means what? you are doing selection, horizontal subset. First, you are taking out the horizontal subset. Then, let me use the mouse here. I will explain with the mouse how to draw the mouse. Insert. How to pick up the, I forgot. Long time back I used. Yeah. Now what we are doing is, you are taking these 4 rows first. Select from where? Select comes later. You are taking a sale table. From the sale table, you are selecting only those rows whose date is 1. This comes this. Now, on top of this, you are taking on top of this, you are taking, let me, there is a pointer. Yeah. Then once it is done, then you are calculating sum. So this is what I have generated already. For video shooting, I did everything, but I did not go to the next slide. And so now if you go to the next slide, it is showing here. See, that means this is a vertical subset. Once these date values are done, these sums are calculated. Right? This completes, this is called slicing, simple aggregation. Then, whenever you do slicing, so for example, if you take, there may be a data cube where you are selecting for a particular time the location and product sales. We have 4 different products and we have 5 different locations. So it is a square. From a cube of different squares, I am taking one square where date is 1 or particular city is 1 something. Then it comes a slicing operator. Then dice. Dice is, as I said, it is a focus on subset of member values, and you are replacing dimension with a subset of values. And dice operation always normally followed with slice operation. That's why mixing, slicing and dicing, or dicing and slicing, everything can be done. For example, if I take here, if a slice is done, under this slice, I want to print only for particular location, Calcutta. That means the product sales at Calcutta only I am taking. So that is a dice. So it is showing product is dice. Right? So it imitates. Now comes the next one. How do you do the aggregation using group by class? There is a spelling mistake. Anyway, it's okay. Yeah, group by class. When you take group by class, see the group by class is, I want to say, for example, I want to take a print, I want to print the total sales on each day. Total sales on each day. So how do we do? Date is grouped. That means all the rows whose date value is same is considered as one group. All the rows whose date value is 2 is considered as another group. And then within the for each group, in the blue color it is shown. For each group, it computes the total sales, total amount. So then how many rows gets printed here? Can anybody say what will be the output of this? What will be the output of this?
2 rows, sir.
2 rows. Very good. Perfect. 2 rows. So the one row is related to date 1, another row is related to date 2. Okay, date 1 means the date value is 1, date value is 2 is date 2, right? See, is it clear? So how to see, you are, this is only for understanding purpose I'm taking, but if you have a large data, you can't see visually. You have to understand mentally, pictorially, and then write a query. Suppose the query, if I say, here I have written query, select date, that means date column plus some amount. Some amount is the nickname for this summary, and group by date. That means I am grouping over date value, and then you get this thing. Now the same query, I will ask you, you please make a note and write a query on a paper or on a notepad by yourself. Note down the question. Find the average amount for each store. Find the average amount for each store. Okay. Now I will ask randomly, maybe Dr. Sarath can answer this question. Find an average amount for each store. How do you write SQL query? Dr. Sarath. Dr. Sarath, are you there? Yeah.
Yes, sir. Yes, sir.
Yeah, please write. You can tell.
Sir.
I will write here.
Okay, sir.
This is a kind of practice for you.
Okay, sir.
Here the question is, find the average amount for each store.
Okay.
Yeah. So what kind of changes I want to make on this query? Ultimately my output should be like this.
Okay.
This is start working.
Okay.
Yeah. Store ID.
Yes, sir.
Then average amount. I want 2 columns, right? So for each store ID, what is the average amount? For each store ID, since there are 3 different stores, I should get 3 rows.
Yes, sir. Yes, sir.
So what changes I should do it here? So this value has to be replaced. This
Yes,
value is to be replaced by which column?
Group by date.
Group by store ID now.
Okay, sir.
Because I want for each store, right? So group by store ID.
Okay.
Then whenever a group operation is mentioned, this value also will be a store ID.
Yes, sir.
And then this needs to be replaced with ABG,
Average amount.
Average.
average bracket ANT. That's all.
Yes, sir.
If you do this, then what do we get? S1.
S1 22.
S1 12 plus
22 point something.
44.
Yes, sir. 22 point.
Yeah.
22.3.
22.3, sir.
55 67 by 3. Okay.
67 by 3,
22.3.
sir.
Yeah.
Sir,
Similarly for S2,
S2 is
6.
12, 6, sir.
S3,
S3 only 50, yes, sir. Only one amount is there.
now what you understood, if I want to use group by column, see, find the average amount for
Yes,
each
sir.
store. So we don't know in database here, because I am showing you, you are able to see. In a database, there can be several stores. Thousands
sir.
of stores may be there, right? Now, in the same way, I can say, can I get the average amount for each product?
Each product, okay, sir.
So simply you have to replace store ID by product ID.
Yes, sir. Yes, sir.
Right.
50.
Now one more complication I will tell. Can I get average amount over each day for each product? See, within the date we have 2 products.
Yes, sir.
P1, P2. Date is equal to 1, have two products. Here also we have one product. So now what I want, within the date, that means one P1 average amount, one P2 average amount, two P1 average amount. So how do we change? It is a multi-column query. So
Yes.
comma, date, comma, product ID. Here I have to write a product ID. So once you do product ID, then group by date product ID average amount. Then you get a 3-column table. See, remember, any number of columns, whatever the database you have, the entire summaries can be created very easily using this query.
Okay, sir.
Right? So this is how we get
Sir,
the
a
answer.
small query.
Yeah.
Sir, here in SQL we are writing only sum, no, sir. Then how are we getting average, sir?
No, here sum needs to be replaced by AVG amount.
Okay, sir. Okay, sir.
AVG is a built-in function.
Okay, sir. Okay.
AVG, you have to replace with this. That's why I rounded off.
Okay, sir. Right.
Okay. I'm not saving this file because it may disturb. So now so this is how aggregation is calculated, right? So there are other overlap operations. Drill down, as I mentioned, add more
Sir,
details
small
to a
doubt, sir.
dimension. Yeah.
Sir, in the SQL code from sales is there. What is the significance of from sales? Can we ignore the sales in code?
Yeah. See, it's a good question. What is the significance? Sale is a table name. Every like for us, everyone will have a unique name because this entire table is considered as known as one identifier. It is identified. It is identified by sale. So that means sale dot product ID, sale dot store ID, sale dot date, sale dot amount. Whereas here I am showing the answer means, for understanding purpose, I have written this table. This is the answer of the result, answer of the query. So this is every answer can be stored in a table using into class. Database into class is there. Using into class, I can store into your ANC table. So every data is linked with a table identifier, which we call as a table name. Okay. So here sale is a table name. Clear?
Thank you, sir. Thank you, sir.
Then drill down, add detail to dimension, already I mentioned. Roll up, remove detail from a dimension. And then recalculate measure values. Sometimes your measures may not be directly present in a structure, but you may have to recalculate. For example, sum, average, max, min, all these things are not there, but we are recalculating. And then pivoting, rearranging the dimensions. For example, here see, add amounts by day product. Add up amounts by day product. So that means what? See, what we have to do, first step is what columns I should consider. That's why I have represented as 2 squares. I have to take product ID, I have to take date, right? So date, day, product. So day is to be grouped. Then within the date, product should be grouped. Then I should compute some amount. So once you do this, this is how grouping is done. See, now these two columns values are taken for all the database tables and they are grouped together. So your group by class does this. This is for understanding, I'm explaining. Your group by class divides the data that is identified into different groups, 3 groups, because we have day product groups. Within the date, product ID is also there. That's why 3 groups are prepared. Then for each group, again amounts are calculated. Once you get this, amounts are calculated. So if you navigating from highest level to lower level, it is called drill down. If you going from bottom to top, it is called drill up. So to understand the drill up and drill down, Only I'm telling. From this, what you can notice from this is whatever things you want to do that you can do in SQL by rewriting queries in different fashion, by using different kinds of aggregation. In group by class, by adding one column, two column, three column, all the columns by putting different kinds of aggregations you can do. That's called drill down. Then comes what is the relational DBMS support? This is about ORAP operators, relational DBMS support for OLEP. So in data warehousing, the fundamental operation used is aggregation. Whatever the power SQL is having in the software, that power of the software is utilized for performing aggregations in most of the commercial databases. There are different commercial databases are there, such as Oracle database and Ingress, etc. All these operators are enhanced. They enhanced the power of SQL by revising the group by class. So if you take the group by class, already I said group by group list is the group by class. Group by date product ID, group by date to sales, etc. Right? So as for the standards, this group by basically helps you to combine all the results into a single structure. That single structure combination is done with union queries. Suppose if two columns are there in group by, we will have a 2 to the power of 2 combinations. 4 aggregations are there. For example, if we take simple example, course number, student ID. Right? Course number, student ID, marks. As a teacher, as a principal, I can ask what is the course average. That means I am grouping all the students with respect to course, and then I am calculating the average. Then and also I'm interested what is the average of each student or all courses registered. That means it's CGPA. So you group by roll student number. That is another query. Another query is what is the mark obtained by the student in each course, by a particular student in each course. So it is a course roll number combination. Then what is the grand average? Total average marks of all students for all courses. So if you see, we have 2 attributes are there. We have 2 to the power of 2. That means 4 aggregations are there. So if the results of all these 4 aggregations are combined together, then it becomes combining is done by using union. The union operation is basically integrates all the results into a single structure. So that single structure integration power, instead of writing different queries and then combining, adding dummy column, all these things you need not do. By using these extensions, by simple group by class, I can get the values. That is called relational DBMS support for OLEP. So roll up and cube are simple extensions, because here you do not have those who are having Oracle 7 software, Oracle 8, these can be practiced. These are all extensions of group by class. But we are not going into the details. I'm stopping here because we don't have software to demonstrate all these things. But what I'm saying is data relational aggregation support is already power is there in the database engine. Then comes a cube admin demonstration. See, this is how SQL complicated query is shown here. Simple example. See, if I write a query like this, I get a report like this. So what it is giving? Country-wise sales for each country-wise internet sales, direct sales. Internet and direct sales for each country. See, if you observe here cube is used, group by cube. See this query. group by cube. Here you have 2 columns. 2 columns means 2 to the power of 2, 4 combinations. So here if you observe here, internet sales in India, total sales of internet in India, total sales of internet in USA, total sales for all countries for internet, it is given here, right? Total sales of both the products for each country, it is given here, right? And then grand sales, total sales for all countries for all products, it's given here. So if you observe how many aggregations are there, 2 square, 4 combinations of aggregations are there. So instead of writing 4 different queries using union operation, combining the results, everything is a cumbersome process. So this was reduced, the process is reduced with a simple extension called group by cube. So that same SQL select channels from, this is a combination of 4 columns. See, your database consisting of sales, customers, times, channels, countries. And then these are the conditions. These are used for filtering. These are called where conditions, right? And then a complicated result, complex result is computed in the database itself so that the results are displayed very nicely in the form of report. This report is known as cross-tab report. Cross-tab report. It's clear? Understood? Hello?
Yes, sir.
Yes, sir.
Right. Then roll-up. Roll-up is also similar thing, but roll-up won't do a transaction of all combinations. Roll-up will do only combinations over the attributes that are mentioned in the group by class. That's the only difference. So easy to use and easily efficient. See, I'll explain how it will come with the example. All the syntax, etc., I'm skipping because you can easily understand this syntax. So rollup, what rollup does is, rollup performs extensions on a particular attributes here, group reference list. Whatever the reference list is given, suppose if k attributes are there in the group by class, it will compute k plus 1 aggregations. Simple example is, if I replace this cube by rollup, it will do total sales for each country, and then followed by total sales for each channel, then followed by grand sales. So when 2 attributes are there here, it gives 3 aggregations, but it won't give all possible combinations. That is the only difference. Right? So for data warehouse administrators, summary tables, using summary tables and rollup can simplify and speed up the maintenance of summary tables. So it speeds up the activities. That is the advantage we get here. Then cube. As I said, if n columns are specified, there will be 2 to the power of n combinations of subtotals are there. This is the syntax for cube. I'm skipping this. Now, can we compute subtotals without using cube? So the answer is yes. Subtotals can always be computed without using cube with grouping set operator. But again, grouping set operator, unless you have Oracle 8 above extension in your system, you can't execute. But the answer is grouping set. So grouping set operator, instead of computing all possible aggregations, you can decide under which combinations you want aggregation. If k attributes are there, cube contains 2 to the power of k combinations. Instead of that, you want to say only less than the 2 to the power of k combination, then you can use grouping set operation. So in that case, we call a grouping set operation. Okay. So therefore, program, you can write a program, you can write a query, and then you can easily determine which rows are there in the subtotals, which I have already explained. And in the results, in order to make compatibility with union, we always have dummy columns, which we call as null columns. Null values are created and then added. So that's why union operator is very important, because if you want to combine two results of a subquery, you need to use a union compatibility condition. Without satisfying the union compatibility condition, we cannot combine the results of two subqueries. So in order to make it union compatible, you add dummy columns wherever there is a less number of columns. If some result is having 3 number of columns, if another result is having 2 number of columns, add a dummy column and then make it 3, so that both can be combined, so that all aggregations can be printed in a single go. That can be reoriented in the form of this structure called crosstab report. So that is where your visualization tool helps you here. But ultimately, at the back end, computation is done by the database engine. Visualization you can do using front end or using any program tool, R tool or Python. So this is where the OLAP structure is very much useful. So I will stop here for today. This completes the last but one lecture of this session. So we will continue this part, remaining last part of this lecture tomorrow. So if you have any questions, please raise your questions, I will answer. Any questions? Is it clear? Today I talked about the importance of OLAP, what are the different operators on OLAP, and I already uploaded my lecture material in the website. Please download the lecture material and then start reading. If any doubts are there, you can ask in the next class. Okay. So I covered all the points. Tomorrow I will talk about different types of OLAP systems and how they are coined and its importance. Okay. Clear?
Yes, sir.
Yes, sir. Okay, sir.
So if there are no questions, thank you all. So we'll meet tomorrow again at 7 o'clock tomorrow.
Thank
So
you.
tomorrow after my class is over, in between I may put some quizzes and questions, etc. Please keep updating and then check the deadlines and then complete the questions in order to make the assessment. Okay. Right. Thank you.